All right, so today we're going to do some data projections and more sophisticated queries. But before we do, we have to have a little bit of set theory, either review if you've seen it before, or some of these things might be new, right? So what is a set? Well, just like in Java, a set is an unordered collection of unique elements of similar type. Now, if you go back in time, say 25 years, where Java was created without that Langle-Wrangle parameterization polymorphism, then you could have a set that had dissimilar types. You could put integers in there, and then you could put doubles in there, and you could put strings in there. And it's just absolute chaos. That's not what math says, right? It's got to be similar types. There are some instances where you want to talk about dissimilar types, but very few and far between. And so they added parameterized polymorphism. You don't just have a list of, you don't have a list of anything. You have a list of integers, or you have a course of sections, and sections have a list of people, right, or the T's that are extending students, right? And so that's what you were doing in your lab this week. In math, we use the following symbols, right? A, B, C with the curly brackets. B is 1, 2, right? So those are two sets. Now, understand that we are using curly brackets here. Over here in, I think we showed it before, but select everything from game where game ID is in, right? A set 3, 5, 11, right? Did we do the in clause? We did? Okay. In any case, let's go ahead and review it here, right? The game ID 3, 5, and 7. The in here is a set operation. Even though over here in SQL, we don't use the curly brackets. That's not correct syntax, right? But over here in math, we use them. In math, if we were to use this, what would we be looking at aside? Right? What if I said, say, I don't know, C comma D, right? What does that more look like? Or here, let me give you something more familiar. X comma Y. That is a tuple, just like Python. They're a tuple. It's a pair, right? X comma Y brings to mind the Cartesian plane, right? A point in 2 space, right? That is an ordered pair because the point 5, 10 is very different from the point 10, 5, right? And so that is an ordered pair instead. But we have, again, that symbol in mathematics where we've got X is a element of the set A. All right, we've seen that now again in 235. All right, how do you negate that? Yeah, just a line through it, right? By the way, do you know the LaTeX for that? All right, yep. Just go ahead and type not in front of anything, and it'll automatically put a kerned line through it, right? So undo, undo, undo. There we go. All right, go back. All right. You can do that over here too. How would you do it? Not in, right? There we go. Now we're getting every single game that doesn't have one of those 3 IDs. Okay? All right, well, we also have other things. For example, what if I were to write this? Right? That kind of goes hand in hand with X. If X is in A, then X is not in A, and that overline there is going to be the complement set. Right? If you want to look at it from the Venn diagram perspective, here's A. Everything outside of A is in the complement set. Okay? And you also have cap and cup, which are going to be union and intersection. And yes, we do have union, and yes, we do have intersection kind of in a form in SQL. Why? Because all these things are based on sets. Okay? Now, let me start with this and we'll type it out. All right. What is this going to look like? All right. So if I take A and do something with B, then I get a new set here. First of all, what is that something called? Have you seen this symbol yet in set theory? All right, so what is this called? Cartesian product. Another word for it would be a cross join, and that's why we use this cross right here, or just a join. And that's what we're going to be doing with our databases. We're going to take one table and another table, and we're going to join them together. Before we do that, though, let's remind ourselves of what it looks like in math. If A is ABC and B is 1, 2, then what is one element in this cross join, in this Cartesian product? A1. A gets matched with 1. A also gets matched with 2. What else? B1. B2. What else? C1. Hopefully you get the pattern now, right? C2. Right. So everything in the first set is matched with everything in the second set. Consequently, what are the cardinalities of these? Right? There's the cardinality of A. What is it? 3. Right? What is the cardinality of B? 2. Consequently, what is the cardinality of A times or cross B? How many things did I write down there? 1, 2, 3, 4, 5, 6. 6. All right? Why? For each element over here, we have an element over here. Right? If there are n elements over here, m elements over here, then we're talking about a result with n times m. Okay? All right. So let's try to do that over here in my database. What I'm going to do initially is, here's a reminder of what the database looks like. I want to know who published each of those games. So I'm going to take the publisher table and the game table, and I'm going to Cartesian product them, or in the context of databases, we call that a join. Join them together. There are going to be 3 columns over here in the game table, 2 columns over here in the publisher table. So when I join them together, I will end up with a 5-column result. Okay? Let's do that naively first. Select everything from game, join, publisher. Right? I get a lot of results there. Right? A lot of results. Why is that? Well, first of all, let's look at the results to see if they make any sense. Did LucasArts publish every single game in my database? No, they only published 3 if I recall. Right? Did Sony Entertainment publish every single game in my database as well? Right? No. Right? Did Square Enix publish every single game? Sega publish every single game? No, Nintendo publish every single game. Why? Because this is just a pure cross-join. This thing right here. Right? Let's go ahead and prove it. How many games do we have? 22. How many publishers do we have? 31. What is 22 times 31? Remember, you can use it as a glorified calculator. 682. Well, how many results are in this naive cross-join? 682. Right? Does that make sense in the context of our database? No. Right? How are these tables related? How do you know that this game was published by that publisher, or that this publisher has published these games over here? Because it's a one-to-many relationship. The what? The keys. We called this a foreign key. We called this one over here the primary key. Only when those two things match. Right? So once again, let's go back over here to the mathematics of it all. Right? So have you seen? You might not have seen this yet. R is a subset set equal of A cross B. There we go. Right? I didn't misspelled it. Subset, excuse me. There we go. All right, certainly you've seen this symbol right here, right? That's a subset, right? A, B, C is a subset of A, B, C, D, E, F, G, right? Because it contains everything in the original one, in the one that it's a subset of. If you want to look at it as a Venn diagram, here's B, and here's A completely inside of it. It's a subset. Of course, A could be equal to B, in which case they're equal, right? That's what this little line under it means. If you want a proper subset, it would look something like this. Have you seen that? No, that's a proper subset. It's a subset, but it's not equal. So it's there's an element over here that is not in this set over here. Right? That's all right. We're not going to do that. All right. So what is this called, and why did I say that it's an R? R is a relation on the Cartesian product of A times B times B. Right? In other words, it's a subset. Right? Elements are in the relation only if they match some criteria. Right? So, for example, here's something that you might eventually see. R is a subset equal of, say, math PBR times math BBR. There we go. So what is, did I have too many? Nope, there we go. All right. What is this R right here? The stylized R. It's real numbers, right? This scripting is called Blackboard bold, right? Right there. It's math BB, Blackboard bold, right? Because if you were to actually write up on a whiteboard or on a chalkboard, can you bold things? No. So instead, what you do on a chalkboard is you give it a little bit of a script. For example, I would write R's as this right here. And that's a habit that people got into, and then they added it to LaTeX because it's a nice little stylized thing. Right? I think you could put any letters that you want in this. Rectangle. Okay, no. Only A, B, C. Okay. Any capital letters are supported. Right. All right, there we go. All right, so what such that x comma y is in R, if and only if x is less than y. Right? There's a relation. There's a very basic relation. 5 is related to 7. Why? Because 5 is strictly less than 7. But is 7 related to 5? No, because 7 is not strictly less than 5. Right? That is one style of relation that you can do. This is a predicate right here that is either true or false given x and y. If it's true, then that pair is in the relation. If it's false, then that pair is not in the relation. It's in the set or it's in the complement of the set. We can do the same thing in databases over here. You told me that it was related through keys. So what I'm going to do is I'm going to modify this join, right? Select everything from game, join publisher, with a relation on it. Remember what we're doing here? RDBMSs? What does the R stand for? Relational Database Management Systems, right? Good old Edgar Codd here was using mathematics that was hundreds of years old, right? So join publisher on publisher ID is equal to publisher.publisher ID. Right? Now what I'm saying here is I only want results that match. The GTA series was indeed published by Rockstar Games. Zelda, Super Mario Brothers, Zelda 2 were all published by Nintendo. Right? Mega Man 3 and 4 were published by Capcom, but remember we've got an intentional mistake here, Eidos, that we'll fix later on. Okay? All right. So let's walk through this. This is a basic inner join. A basic inner join will join records from table A to table B, right? With such that only pairs or combinations, I'll say, combinations that match the on predicate or clause are true. Right? So anything that this is not true, like that they're not equal, in fact, you can go ahead and do that and get the complement set. Right? When they're not equal, then I get weird results, but I don't get all the results. GTA 1, 2, 3, and 4 were published by LucasArts. But the things that LucasArts actually did publish, X-Wing versus TIE Fighter, they don't show up here at all, right? Because I've negated it. I've looked at the complement relation instead, the complement set. Right? You don't usually do that, though. That's weird. Right? Why did you design your database here just to go in the complete opposite direction? Okay. All right. So some nice syntactic sugar. Right? For example, you can, normally this is what's called an inner join. First of all, you can omit the inner, right? Second, you can use aliases to shorthand a lot. For example, select star from game as G. Inner join, I'm going to immediately leave off the inner now. Join publisher as P. On, now that allows me to use those aliases. Instead of game.publisher ID, I can say g.publisher ID is equal to p.publisher ID. Right? In fact, it is so common to do this, you can even omit the as. So I'm going to go ahead and say game G, publisher P, on those values. Look at the order here, right? Where did I start from? I started from the game table and then joined over to the publisher table. As a consequence, the 3 columns that appear first on the left, right? There's game ID, name, publisher ID, and then name, right? So these 3 are going to be the game table, and then these 2 are going to be the publisher table. Yes, you can switch things around, right? Changing the order changes the order of the columns. So there we go, right? I'll go from game G, or from publisher P to game G. There we go. And you see those 3 columns are now over here, and these 2 columns are over here. Right? The order matters because what you can do, all right, actually, the order doesn't matter. The order does not matter on the predicate. We've all seen predicates from 235, right? A predicate is just piece of X. It's something that's true or false. You just don't know until you input X, right? So I'm going to go ahead and change this around. Right? There we go, is equal to that. Right? A is equal to B, B is equal to A are the same statements. So you'll end up with the same results. Right? Generally though, what you would do is if you go from publisher to game, then it should be publisher, then game. You follow the same order. Right? You can also, actually no, well, I haven't talked about left joins yet. Right? Observe though. Do we get all the publishers? Are all the publishers represented? Right. So for example, let's come over here. I'll tell you right now that Sony Entertainment Corporate Computer, or Sony Computer Entertainment or something like that, right? They didn't publish any games here. Do they show up at all? Not that I see, right? Why is that? Let's go back to our database here, our ER diagram, entity relation diagram. Remember that this is the parent record. This is the child table. Can a child exist without the parent? Those are called orphans, and we don't allow that in a well-designed database. But can a parent exist without the child? Yes. In particular, Sony Entertainment Company up here does not have any games published in our database. I want to preserve those records. So what I'm going to do is I'm going to do instead what's called a left outer join. Right? So generally, an inner join does not preserve records that have no matches, right, from A to B. Right? However, a full outer join, or left outer join, left outer join does preserve records. So let's go ahead and start at the publisher table. And the only difference that I'm going to do here is instead of a regular old join, I'm going to do a left join. There's the difference. There's Sony Entertainment, Computer Entertainment, right? Did they match any records? Nope. Consequently, what are all the values? Null. Right? But Sony Entertainment is preserved, as is Square Enix and Sega and all of these other values that we never actually entered any games for. Disney, NBA 2K, a different copy of Rockstar. Gearbox. I think Gearbox is ours, right? Okay. So a left join will preserve those records. And just in case you're wondering, is there a right join? Yes, there is a right join. Right? It preserves records from B to A. So if we go ahead and go select everything from publisher, actually let's go game, because then it'll make sense. G, right join, publisher P on, and I'm just going to steal this. There we go. There, same exact result, but remember that the order here matters. So the 3 game columns are over here, and the 2 publisher columns are over here. But we preserved elements from the right to the left. Right? I'm doing that right? Yeah, from the right. I have to mirror myself, and I sometimes get confused. So you're preserving records from the right. Okay. Who reads right to left? I don't. Right. So it is best to use left joins, and always reorder, and not always, but and reorder the columns or the tables so you read left to right. Now there are some instances in which you'll want to read right to left. We'll look at one at the very end. All right. But otherwise, yes, you can do right joins, but why? Just instead of doing a right join, just switch them around and do a regular old left join so you're reading left to right. Right? All right. Okay. Let's look at what that looks like from another perspective here. Here are the student records, right? And we've got Starlin Castro, Anthony Rizzo, Dale Sweem, and Ryan Sandberg here. Right? And we've got email addresses. Right? Castro, 1234, matches with one email address. So consequently, there's one record in the resulting joined. We're joining these two things together. Anthony there, 5678, matches with one record, and we get his record down here, rizzo@cubs.com. Right? Ryan, down at the bottom, 9988, matches two records, so consequently we've got Sandberg here twice. Yes, there's repetition of data, but that's in the result of the query. That repetition is not being stored in our database. Sandberg is only stored once. When we join him and he's duplicated now, there is redundancy, but that's what you want. That's what you want in your report. What about poor old Dale Sweem here? Anybody know who Dale Sweem is? He was the manager, 2 managers before Joe Madden? No? Okay. Anyway, Dale Sweem. He was fired, and that's why I took out his emails. Right? Does he appear here at all? No, because there is no matching 1122 over here. Okay? All right. Here is the difference with a left join. Exact same results, but Dale Sweem, even though he doesn't match any emails, he's preserved. Okay? If you need to preserve records in the original table, going to the next table, you need a left join. Right? You don't use the keyword outer. You just use left join. Just like you don't use inner join, you use just join. Okay? All right. Cool. Now, how can we do some things with this now? Right? My goal is to determine how many games each publisher published. Right? ... So if I just go from the publisher table, let me go ahead and grab this. All right. There we go. And remember, white space doesn't matter, so if you've got a long line, just go to the next, break it up by keywords, like I'm doing here, right? Always begin a line with a keyword. Right. There we go. So if I were to go through this manually, I'd say, well, LucasArts there, they've published 3 games, right? Square Enix, well, they have not published any games, okay? Nintendo has published 1, 2, 3, 4, 5 games. Right? I don't want a report that looks like this, though. I want a report that looks more like LucasArts 3, Nintendo 5, right? I want something that looks more like an actual report that you would see given to a human readable report. So what I'm going to do is I'm going to say p.name as publisher. Remember that you can use aliases. Right? There we go. I'm getting the publisher name. Let's go ahead and get, for now, the game ID as well. G.name as game title. Right, there we go. And then go from. There we go. Oops. What's wrong? Oh, comma. Sorry. Forgot my comma. There we go. There. Now I'm getting the game title. Why did I use aliases here? What if I didn't use aliases? Let's take that away. Let's take that away. Right. I'm getting name. Now, if you're familiar with the data, you'll know which ones are the games and which ones are the publishers. But if you're not familiar with the data, having 2 columns of the same name, is that a good idea? No. So, here, I'm going to use aliases. Now it's completely unambiguous. Here's the publisher, here's the game title. I don't want just the game titles, though. I want to take these 3 game titles and collapse them down and simply just count them, 3. For that, we need what's called a data projection. Right? So consider the projection of objects. For example, you can go from 3D down to 3D down to 2D. Right? Now, the example that I have in my book is, because I wanted to just draw it, it was a nice little picture. Take a cube. That's a 3D object, three-dimensional object. Project it down onto 2 dimensions, onto this table. Right? What do you get? A square. Right? So going from 3 dimensions down to 2 dimensions is a square. Right? Now, if you project it down from 2 dimensions to 1 dimension, what do you get? A line segment. Right? Line segment, 2 dimensions, or sorry, 1 dimension down to 0 dimensions. What do you get? A point, 0-dimensional point. Right? What if you went in the opposite direction? If you had a cube, 3 dimensions, and you projected it up to 4 dimensions. Tesseract, right? The made famous by Marvel movies, right? And usually, you know, when you take that 4-dimensional cube and you project it down onto 3 dimensions, you don't get a cube. You get a cube within a cube, and then all the vertices are connected on the endpoints, right? And then you can project it up to 5 dimensions, and you get 2 tesseracts, and they're connected. They're all connected, right? It's because we're 3-dimensional beings. We cannot fathom something in 4 dimensions, 5 dimensions, right? Because there's no way to visualize it. Once we visualize it, we're in 3 dimensions, right? But you can do that with data, right? For example, let's look at this data. Where is it? There we go. So this data has 3 dimensions. So we could visualize this, right? X, Y, and Z, right? It's got a title, an author, and the number of copies. So I've got a bunch of books in my library by their respective authors, and then we've got various copies of them. What I want is a list of all of the authors along with the total number of copies of every book that they have. So for example, Norman Mailer, he's got 2 books, 13 copies, 10 plus 3. Douglas Adams, we've got 3 of his books, 4 plus 2 plus 1, we've got 7 copies. And Orson Scott Card there, we've got 7 copies, so 7 for him as well, but 1 book. Right? What I'm going to do is I'm going to group them. Right? I'm going to group them by their author. When I do that, I rearrange them. All the Norman Mailer books are right next to each other. All the Douglas Adams books are right next to each other. This looks like an order by clause, and it could be if you ended it right there, but this is going to do another step that I've not yet revealed. I'm going to project that down. I care about the author and the number of copies summed up. I'm going to take away this dimension right here, just like I took away that dimension on a cube. I took it from 3 dimensions, flattened it down to 2 dimensions. I'm going to get rid of this dimension right here. But in so doing, I'm going to sum up all of those copies, 13, 7, and 7. This is what I want, okay? So how do we do that over here in SQL? Here's my first attempt, right? So let's go ahead and group by publisher ID in the game table, ... So select everything from the game table, from game, group by, well, actually, let me just show the table here, right? So does it make sense to group them by their names? The names are kind of unique, right? If you group them by their names, would it be any different than what you have here? No. The game ID is guaranteed to be unique. You are not going to get any difference if you group it by the game ID. Let me show you. Group by game ID. Right? You're going to get the exact same result. Why? Because they're all unique. What's not unique here? The publisher ID. So let's go ahead and group them by the publisher ID. Right? That's the first step. Now it's not going to be this exact visualization here, but you'll see that I only get 1 copy of LucasArts 1 here. 1 copy of Nintendo 5. Right? Where am I getting this name over here? It just so happened that that was the first one. If you take this and you squish it down, you only see one side of the cube, right? So you're only seeing 1 title here, okay? So I want to preserve, say, the publisher ID, but now I want to get some aggregate information out of that. I want to count the number of records. Right? Now remember, if I didn't have a group by clause here, what would I have? I'd have select everything from game. I would have something that looks like this, where I've got GTA 1, 2, 3, and 4, publisher ID 6. Right? I'd have 4 records. I want to collapse them down and get this 4 out of it. So I'm going to count the number of records. There's the publisher ID. 6 was Rockstar Games. There it is. And it's 4. Right? Remember LucasArts? They've got 3. Remember Nintendo? 5. They've got 5. Right? It's much better if you alias this stuff now. Publisher ID. Okay, I'll keep that. But count doesn't really tell me anything as number of games. Published games. There. That column is way better than just count star. Okay. Still a problem here, though. All right, I remember what 1, 5, and the rest of them are, but who the heck is 16? Is 16 meaningful to us at all? No. Can you get who the publisher is if you only stay in one table? Nope. So let's take both of these concepts and combine them into one. Let's go ahead and join and group by it all together. Right? So let's come down here. Right? So as number of games, join publisher P. From game G, join publisher P on G dot publisher ID is equal to G dot publisher ID. Group by publisher ID. That's probably going to be ambiguous, yeah. Which publisher ID do you mean? Well, I'm saying that they're equal, so they're going to be the same, so choose either G or P. It doesn't really matter because they're going to be the same. Oh, sorry. Was that what it was complaining about? Maybe it is smart enough to figure this out. Nope, okay, I do need P or G, it doesn't matter. Oh no, what am I doing? All right, let's go ahead and select star. I have to reread this now. From game G, join publisher P on G.publisher ID is equal to P publisher ID. This should work. There we go. Okay. Okay, all right. Yeah, we're not there yet, I guess. All right, so there we go. Publisher 1, 5, 6, ... Okay. Except that, are you getting Sony Entertainment over here anymore? Nope. So let's go ahead and change the type of join. What join will preserve records? Left join. But remember, the order matters. You are preserving from the left. If you go from the game table, the child table, up to the publisher table, do you need to preserve game records? Otherwise, they wouldn't be there. You don't have orphans. You don't have an orphan that needs to be preserved with no parent. So let's reverse this. Publisher P, left join, game G. Don't have to change anything else. And now you'll see that Sony is preserved. Square Enix, Sony, Sega are all preserved. And they're all going to be nulls. Okay? All right. I don't want just all the records. I want to project them down because I'm grouping them by their publisher ID. So publisher P.name as publisher name, comma, count of star. This is still going to be wrong as number of games. There we go. That works. LucasArts has 3. That's correct. Where's Nintendo? There we go. Nintendo has 5. That's correct. Well, we already know that Sony Entertainment does not have a record. We know that Square Enix and Sega do not have records. Why is it giving me 1? Yeah, well, here's a stupid way of doing it. -1. Remember, you can do basic math, right? But now, is that correct for LucasArts? No. So it's still showing up as a record. And what am I saying? I'm counting all the records, even if their value is null. What should I be counting here? Let me go ahead and go back to what we were looking at before. Copy star. All right. What should I be counting for LucasArts there? The game IDs, the things that are guaranteed to exist. Because Sony Entertainment, when I do a left join, has no games, therefore the game ID is going to be null. What do you think the numerical value of null is? 0. Right. So undo, undo, and let's go ahead and count g.gameID. Right. There. Now all is well with the world. LucasArts has 3, Sony Entertainment, Square Enix, and Sega all have 0s. Nintendo has 5. Right? All the records are preserved. I'm counting the correct thing, and I'm winnowing it down to only the columns that I care about. Right? Imagine if you had this on your first assignment. In fact, usually this is the first assignment. I give you a CSV file of game data instead of patient data, right? But I switch it out every year. I switch it out every so often. And so think about your patient data on your first assignment. If you wanted to know how many people have blood type A, what could you do? If it was all stored in a database, group by blood type, count, patient ID, right? And you've got your answer to that entire report with one line of SQL code and a very, very short one at that. Right? It wouldn't even have to be this long at all. Right? So SQL has some very powerful syntax here. It's a declarative style programming language, a functional style programming language that allows you to do a lot of very, very complex data processing, all on the database end, right, with very, very little syntax. Right? Python would do the same thing, though. Right? You could do a list comprehension of some sort, or a map comprehension with an aggregate function. It's going to. I think you asked about it the other day. Why does it look a lot like Python? It's because both languages are declarative style. Right? Instead, the C, Java, to a point, is what's called imperative style. So what's an imperative? It's an order. I'm ordering the computer to do step 1, step 2, step 3. I'm telling it what to do and how to do it. But I'm telling it what to do, but am I telling it how to do it? No. That's why it's a declarative style, not an imperative style. Right? That's not step 1, do this, step 2, do that, step 3, do that. It is just do it. This is what I want you to do. You figure it out. Right? And it's the database's job to take your commands and formulate what's called an execution plan and then execute it and deliver the results back to you. Right? Awesome. Well, what else could we do with this database? Really quickly. What if you wanted the number of the games along with all the platforms that they're available on? Right, let's go ahead and do that as an exercise. Get a list of all games and their platforms. ... For that, how many tables am I going to have to join? Join it from the game to the availability, from the availability over to the platform. In other words, 2 joins. Right? So here's my first attempt. Select everything from, I can go down to the next line, game G, join availability A, on, how are those two, in fact, how are those two related again? I don't remember. All right. Game availability. Right. What were the IDs of those things? Do I have to do any guessing at all? G.gameID is equal to A.gameID. Why don't I have to do any guessing? Let's go ahead and look at this again. What's my naming convention that I'm following here? The tables are all lowercase, right? And it's consistent. They are all singular. It is not the games table. It is the game table. It contains game records, right? What about all the primary keys? Table name, and then you slap an ID at the end. All exactly the same. What about the foreign keys? Exact same name as the primary key that they reference. No guesswork here at all. Why? Because it's a proper, consistent naming convention. Right? So, on that, join platform P on, I don't even have to remember this, A.platform ID is equal to P.platform ID. Right. There. Lego Star Wars is available on Xbox. GTA 4 is available on Xbox 360. Right? Katamari Damacy is available on PlayStation 2, right? All the way over. Except that, does that look like all the games to you? No. What kind of join did I do? A regular old inner join. Right? If you want to preserve records in the game table that have no platforms, right, that are not available on any platforms, what kind of a join do I need to do from the game table to the availability table? A left join. Right. Now here's a question. Do I need to do a left join here at all? Let's take a look over here. Once I'm at the availability table, I'm going up to my parent over here. Is it possible for me, a child, to exist without my parent? Nope. So you could do a left join, but the database design says you don't need to. You could just do a regular old join. There. Oops. Left join. Oh, sorry. Left join. I do need to. I forget why. I forgot why. Once you join game and availability, right? What about the availability or what about the platform ID here? It's going to end up being null, and it's not going to be preserved over here. Right? That's why. Right? And so I'm going to go all left joins all the way over. Right? GTA 4 is available on Xbox 360 still, and PC. GTA 3 is not available on any system, and you see that the availability, the game ID, the platform ID, the publish year, everything that's in the availability table is null, all the way over to the platform table. Is this going to give me any platforms that don't have any games? No. Why? It's preserving from the left, game to availability to platform. Everything is preserved one way. What if you want a list of all platforms along with the games that are on it, whether or not they have any games or not? Right? So let's do that. Get a list of platforms and all of their games, even those that have no games, ... So select everything. I'm going to start at the other end. I'm going to start everything from the platform table, P. And I will do a left join to the availability on P dot platform ID is equal to the platform ID is equal to A dot platform ID, and then do another left join over to the game table G on G dot game ID is equal to P dot game ID. I about typed platform ID, but is that right? I mean, that'll give me something, but would you expect the game ID and the platform ID to match? No. Consistent naming conventions will make that really apparent and obvious. Right? Oops. From platform P. There we go. Darn it. A platform ID, platform ID. Thank you. There we go. There. All right. Uh-oh. Do we have any platforms? Xbox, Xbox 360. Oh, everything has a game? I don't buy that for 1 second. From platform P, left join availability of A on P platform, left join G, A. Really? All right, let's check it out. Select everything from platform. Maybe. Let's force it. Insert into platform. What do I need? Just a name? Name. Values. Let's do 2. Valve index. Right, and I know, playdate. There we go. There. I've inserted 2 records that are guaranteed not to have any games in there because I haven't entered any games. So now do they show up? There. Okay, apparently everything did have a record. Valve index and playdate. And I'm only mentioning playdate. Have you seen playdate? It's pretty cool. No? Playdate. I mean, it's kind of expensive for what it is, but there we go. It's this nice little handheld, black and white, right? Little small screen, and it's got this little crank over here, right? Does it show it? Okay. I'm not promoting it or anything, but I've got one, and I only mention it because they have an open open API that you can make your own games, and it's written in C, right? So you can write in C and create your own games here. It's kind of, you know, regular old D-pad and A and B, but then it's got this crank that comes out, and you can actually crank stuff. Right? And so that's all. That's why I mentioned that it's kind of cool. Right? It's $200. It gets you a whole season of games. They release 2 every week. Right? But otherwise, there's Playdate, but we don't have any games published on it yet. Oh well. Right? And again, left to right or right to left, the order matters, because if you're only going to use left joins, you need to make sure you're going from here to here to here, and you're preserving records from the left. Okay? All right, we'll pick it up there with more complicated things next time.